This is episode 3 of creating my very own finance app. After learning the basics of creating a full stack app from my dummy project, I feel that I'm ready to start my very first real project. As a refresher, this is currently what I'm making. It is a job tracker which is part of a finance tracker app, where all the jobs will be displayed at the main page. And clicking a job will bring you to either of these two pages. Number 1, a page where you can track your part-time work, and number 2, a page to track your full-time work. And then each of these pages you can add jobs and part-time. With that out of the way, I will now show you the codes of how I set up the front end and back end, show all the jobs, and create the form to add jobs. I will also put up a small mini map at the top right hand corner of the screen so that you can keep track of what I'm explaining. So let's go. I will show you the steps that I did in a step-by-step manner. As I coded all these beforehand, it may get overwhelming because of all the codes that are being there. So I recommend you guys to follow what I highlight using the cursor as I say the things that I did. I created a new folder and started from scratch. I installed Express for API, Node-mon so that I don't have to close the app and restart the game manually, .env to store the private stuffs like MongoDB URL for connection and the port number, MongoDB for database, and Mongoose to interact with the database. I set up Express app by allowing app to listen to 5000, you can choose 4000 or 2000 or 3000, up to you, and Nodemon by putting dev::nodemon app.js at the script part of the package.json file, so that I can type npm run dev to start the app, and Ctrl S if I did any changes. I put the port number 5000 in the .env file, and use it by importing .env.config and using process.env.port in my app function. For cleaner code, I separate the routes or endpoints into different files to avoid clutter in the main file. I created a new folder and file named jobroutes.js to store the routes for my job tracker. In the jobroutes.js file, I imported Express, used the router function from the Express, assigned it to a variable called router, and exported the router module. I imported this jobroutes.js file into app.js and configured the app to use these routes with the prefix /API/jobs-tracker. This means that when a user calls https://whatever/API/jobs-tracker, any subsequent path will be handled by the routes defined in the jobroutes.js file, so that I do not have to repeatedly type the full path. By the way, there is a /API/blah is because it is to differentiate backend and frontend route. When a user navigates to https://whatever/jobs-tracker in their browser, the server will serve the frontend which displays the web page. Then the frontend makes an API call to http://whatever/API/jobs-tracker to fetch or manipulate the data. Then, lastly, the API handles the request and sends the JSON response back to the front end. Next, I will define the backend actions for different routes, which typically involve interacting with the database. There are 5 different scenarios: get all the jobs from the database, add a new job into the database, get a specific job from the database, delete a specific job from the database, and update a specific job from the database. So this is how I do them. When a GET request is made to the /API/jobs-tracker, the backend uses the controller defined with get/ to retrieve all jobs from the database. I'll explain what the controller does later. When a GET request is made to /API/jobs-tracker/:id, where the ID is a placeholder for the job ID, the backend uses the controller defined with get/:id to retrieve the specific job from the database. I will explain what the controller does later. The ID was automatically assigned when a job is added to the database. When a post request is made to /API/jobs-tracker, the backend uses the controller defined with post/ to add a new job to the database. I will explain what the controller does later. When the delete request is made to the /API/jobs-tracker/:id, the backend uses the controller defined with the delete/:id to delete a specific job from the database. I will explain what the controller does later. The ID was automatically assigned when the job was added to the database. When a patch request is made to /API/jobs-tracker/:id, the backend uses the controller defined with patch/:id to update a specific job from the database. I'll explain what the controller does later. The ID was automatically assigned when the job was added to the database. These endpoints are just definitions. They won't perform any actions until the logic is implemented. The logic is basically the controller. If you want to check whether these routes work, you can produce a message for each route and test it in Postman. I will link a video in the description to learn how to do that. Now I will go to MongoDB Atlas website, log in, create a new cluster, then a new collection, which is a group of data. Connect the cluster by clicking the drivers and retrieving the link. I will copy paste the link into the .env file, which I will not show here because there's a privacy reasons. And then import Mongoose that I've installed at the beginning. I will connect the app to the database using Mongoose, then allow the app to listen to port 5000 and then catch any errors if there is any. This means that the app will listen to port 5000 after connecting to the database. Next, I will make a schema file in the schema folder. A schema is a set of structure you give to the data that every data have to follow. This includes a type, whether it's number, string, etc., and whether it's required or not. If the data does not follow this, it will produce an error. It is especially useful when doing a form. Around the schema, I created a model around it. A model is what is used to interact with the database while following a structure defined by the schema. You use the model to delete, add, get, and update data. The model is called with the first letter of the variable name being the capital letter. For getting all the jobs, this controller fetches all the jobs from the database using the job model created just now, sorts the jobs by their creation date in descending order, sends back the list of jobs with the 200 status code. For getting a single job, this controller extracts the job's ID from the request parameter, checks if the provided ID is valid using Mongoose types object ID is valid. If not valid, sends a JSON error. Fetches the jobs by using ID using the job model which I defined just now. If job is not found, respond with a 404 status code and an error message. If found, responds with a job and a 200 status code. For adding a job, this controller extracts job details from the request body, tries to create a new job into the database using the job model which I defined earlier, sends back a created job with a 200 status code. If an error occurs, responds with a 400 status code and the error message. For deleting a job, this controller extracts a job ID from the request parameter, checks if the provided ID is valid, produces an error message if not, finds and deletes the job by ID using job model which I defined earlier. If job is not found, responds with a 404 status code and an error message. If deleted, responds with a deleted and a 200 status code. For updating a job, this controller extracts the job ID from the request parameter, checks if the provided ID is valid, finds and updates the job by ID with the new data from the request body using job model which I have defined earlier. If job is not found, responds with a 404 status code and an error message. If updated, responds with an updated job and a 200 status code. Set up and clean the React app. I changed the directory to frontend and installed React Router DOM. Import browser router, routes, and route from React Router DOM in the app.jsx file. Put in the routes that I want the user to go and what thing you want to come out of it. This is different from the route we defined from the backend, as these routes is what the user are actually going to go to, whereas the route in the backend is used to differentiate which controller to activate. Now that I have the route and the thing I want to come out of it, let's define the thing. The thing is most probably be able to display the data you want from the database at the backend, so let's do that. Install CORS in the backend folder, cd backend, then type npm i CORS. Import CORS at the backend app.js or wherever the main backend app is at. Make sure the app is also using express.json so that it can play with JSON data. At the front end, in whatever page you want to put the data in, import useState. Define the name of the data being received, in this case is the jobs, and then set jobs equals useState with the original value of now. Import useState and init, create a fetch data function, in this case fetch jobs, and make it an async function. Define the data you get from fetching them from the backend as response. Convert it into JSON and put it in the variable of JSON. Check if the response have no error. If so, set the jobs as the JSON. Call the fetch data function in the use effect. With the data stored in the jobs, I then map out the jobs to produce an individual job. Call out the component job list, which is one job, sends an individual job over to the component, where I receive the individual job and show each job titles as explained. At a page where all the jobs are displayed, I want a way to add a job, so I added an add button at the top. When clicking this add button, it navigates to the job form page using the use navigate from React. When the user is navigated to the page, this produces the form page component as defined in the app.jsx page, where I define the front-end route. This is the code for the form page. I define the state variables for each form field, an error message, and initialize the navigation function navigate. The handle submit function is called when the form is submitted. ePrevent default prevents the default form submission behavior. I created a job object with the form data, then send a post request to the server to add a new job. This means that it will go to the backend and then find the post/request and do the things in the controller. If the response is not okay, it updates the error state. If the response is okay, it will reset the form field, clear any errors, log the new job, and navigates back to the job tracker's route, which is the main page. The handle click function activates when the back button is clicked, which navigates to the job tracker. Now for the return portion, I render a button that navigates back to the job list, renders a form with the input fields of the job details. Then for each input field, it is controlled by a state variable, so whatever the user type will be set as the updated variable. When the form is submitted, handle submit is called, where the updated variables will be in a constant job, which will be posted to localhost 5000 / blah blah blah. If there is any error, it will display below the form. So yeah, I set up all the front end and back end of the app and created a new form. So anyways, just my opinion. Bye.